Okay, so for this part of 5.1, we have simple interest and amortization tables. So we have two equations over here. They're fairly important, uh, simply to be able to calculate in our upcoming questions. We have the first question at age 16, May decides to invest $1,000 into an account that earns 6.5% a year. She hopes to have $2,000 for a trip to Cancun when she's 25. So will she have $2,000 when she's 25? So the first thing to do is figure out how much time passes. So when she's 25 versus 16, and that is 9 years. And then our P, which is our present value, would be $1,000. And our R, which is interest rate, is 6.5%. Finally, we can put that into our equation, our first equation, and we can figure out the interest made. And then make sure when you're putting it in your calculator that you are actually putting the percent button. This will give you 585. And then over here we have our next equation to figure out how much total that is. So A equals P plus I. So our present value, or our principal, depending on where you're listening, is then our interest. So we have 1,585, which is not $2,000. So no, she will not have that much money. Her friend, however, tells her to invest in another account that earns 12%. How much will she have at age 25 if she uses this account instead? So here, we're going to change our rate from 6 to 12. So the rest of the information is the same, but this is 12% now. So this part here and this part here are changed. This will give us an interest on that money as 1080, and then you can calculate how much she'll have. So she started with 1,000 and gets 1080 on top of it, which will give her 2080. So yes, she would indeed have enough if she invests with the 12% rate for her trip to Cancun. Ray invests $5,000 in a simple interest savings account at 7.5% annually. If he leaves the money in there for 62 months, how much money will be in his account at the end of 62 months? Now, please note that this is in months and we need it in years. So this is 5.17 years. So that's what T is. And then P is your present value, what you're putting in. And R is the rate. And then we have our equation. $5,000 times 7.5% times 5.17 years gives you $1,938.75 made on interest. And then we want to know how much at the end he's going to have. So this is how much he has at the end of the 62 months. And then how much interest is earned. That is your first part of your calculation, where I is equal to 19. So that's your first part of the calculation, where I is equal to $1,938.75. All right, so the next number is number 3. Mr. Arden invests $250 at the end of each year for 10 years. His bank offers him 7.2% compounded yearly. Complete the following table and answer the questions that follow. So, in order to complete this table, you'll notice that the new balance becomes the current balance. So here we have times 7.2% is going to give us $18. And then he always deposits $250. So you could fill this in here. So in order to get your new balance, you're going to add your 250, your 18, and your 250 together. It'll give you 518. That 518 comes over here, and you repeat the process for every single line. So times 7.2 again, 37.29, and you add the three boxes up together, gives you 805.30. 805.30 comes back down here, times 7.2, gives you 57.98. Add them together, and so on and so forth. So I will fill this table in. All right, so now the table is done. We can come and answer these questions. How much did Mr. Arden invest in total? So he only invested the $250 for 10 years. So he only put in himself $2,500. How much interest did he earn? So then you're going to calculate the difference between how much he has made over here and how much he put in. So the total that he's earned is going to be 3486.90 minus 2,500, which gives us 986.9. Finally, there's a challenge here. How much would you have to invest in an 8% simple interest account if you wanted to have $5,000 in 6 years? So this one here, you're using this equation. You want to have made $5,000. You put your other information in, and then you solve for P. So you need to isolate it, which means it's going to be 5,000 divided by 8% times 6, which gives us, I'm running out of space, 0.48, and 5,000 divided by 0.48 is 10,416. So that's how much she would have to put in to make $5,000.
All right, so this part here is a tech tip on using the TVM solver to solve compound interest problems. So if we follow along with just kind of the worksheet, TVM stands for time value money. It's a program that performs financial calculations. So there's some calculators that do it. We don't have those calculators. They're quite expensive and they really aren't common. But we do have the internet, and the internet has everything. So there are TVM solvers on GeoGebra, which is a very good one. So let's work through example 1 and use the TVM solver that I have on the right of the screen. So here, Tanya buys $1,000 GIC that pays her 4% interest, so I'll highlight some information, per year, and is compounded annually for 3 years. Now, N is the number of payments, so the number of times she's getting paid, so it's 3 times, there's 3 years. I is the interest rate, so that's a pretty easy one, it's 4%. PV, I'll zoom in a bit, PV stands for present value. So it's the amount that you're putting in. So she's putting in $1,000. PMT stands for payment. In this situation, we're not doing any payments, so it's going to just remain 0. Future value is what we're looking for. So leave it at 0 and we'll click solve for FFE when we get there. PY is the number of payments per year. It's a one-time investment. So she's not adding in money every single year. She's just putting it there and it's staying there. So PY is 1. CY is the number of times its interest, the interest is compounded in a year. So that's 1 time because it's compounded annually. So 1 time a year. And then the last line in the actual solver over here is about different stuff. And we don't have that one, so we don't have to worry about it. Now, let's go plug all these variables in, all the values in. So we have 3, 4, 1,000. And the other twos are already set to 1. So now we're going to click solve for FV. And you'll notice here that it says minus 1124.86. So when it's minus, it means money is getting taken away from you. So in this situation, if we actually come back here and put a minus in front of FV, in front of PV, so 1,000, and we solve for FV again, it changes it to a positive. So it's minus 1,000 because the $1,000 is leaving your account to go somewhere else. And then you will get back 1,124. All right, so this part of 5.1 is about future value. So the future value is the amount the principal will be worth in the future. Your present value will be worth later. So your future value is your present value, or your principal is the same thing, plus your interest. So PV plus I. This is basically the exact same equation we had in another worksheet where it's A equals P plus I. You just use different words. All right. Okay. So Canadian Bank posts the following table on their website. A term deposit, or money deposited in a bank for a set amount of time, pays simple interest. So calculate the interest earned in each case on a term deposit of $2,000. So the first one's already done, so it's $2,000 each time, so we can just put the present value in already. And then we can just copy over from the table on the right all the different rates, so that's already done. And then so the first one's for 1 year, and it's already done, so you can see there's 2,000, which is your present value, times your rate, times the years. So now we're going to go do the next one, which is 2 years. So I is 2,000, once again, times the different rate, times 2 years. Now don't forget to put your percentage button in the calculator. This will give you 124.00. The next one is for 3 years. So I will give you 2,000 times 3.15% times 3, and that gives you 189.00. And then here you have the last one is 5 years. So I is 2,000 times 3.30 times 5 gives you 330. Now we are going to determine the future value of each term deposit. So the first one's done again for us. You have to remember we're starting with $2,000 each time. And the future value is just adding your interest earned to your present value. So let's recopy our interest earned. And then just add it to the 2,000. And there we go, that table is filled out.